So, since we've been doing unit analysis in chemistry, I'm just making a video here to show you how it works. So, the first thing you need to understand is that unit analysis goes off of how fractions work. So, basically, what we need to understand is that we're multiplying a whole number. When we multiply a whole number by a fraction, what we're really doing is we're multiplying the numerators together. So basically 2 times 1. So these numerators are over on the side. So I've got my whole number in green here. And I've got my fraction in blue at the top and orange in the bottom. So the whole number right here, numerator right here, and then denominator right here. So when we multiply a whole number by a fraction, what we're really doing is we're multiplying these two values together. So what really happens here is we end up with 2 times 1, which is just 2, over, and then the denominator is still 4. And so when we reduce this, hopefully you see 2 over 4, or 2 divided by 4, is the same as 1 over 2, which is just 0.5. So what actually happens here, and let me just rewrite this again as 2 over 4, what really happens is when we have a 1 in the numerator, we don't even really need to plug that into the calculator. It's just the same as what the whole number is. So what we end up with here is just 2 divided by 4, which gives us 2 divided by 4. So if we look down here, 1 times 1 over 2. So we have a whole number multiplied by a whole number multiplied by a fraction. So 1 times 1 is just 1. And then what's left in the denominator is still that 2. So 1 times 1 is 1, divided by 2 is 1 over 2. So when we simplify that, it is just going to be 0.5. Again, we don't need to do the 1 times 1, because it's just the same as the whole number when you have it multiplying by 1. If we look over at the second example here, we have 4 times 1 over 2. Again, we have that 4 times 1 here. So that's just going to be a 4, right? And 4 in the top. And then it's still divided by 2. So 4 in the numerator, 2 in the denominator. 4 divided by 2 is just 2. This also, let me put in another example. So if we have, let's say, 4 times, again, a fraction, and we'll say it's, this time it's 3 over 1. So again, it's 4 divided by 1, which is just 4. 4 divided by 1 is 4. But we have a times 3 now. So the 1 is now in the denominator. But again, 4 divided by 1 is just 4. And so we end up with 4, and then we still have this 3 in the numerator. So it's 4 times 3. So now the 1 has gone away, and 4 times 3 is just 12. So this last example over here, we have 33 times 48 over 33. So immediately you might see this and be like, what the heck is going on? It's a wild fraction. So this fraction here, I don't know what that is off the top of my head, but since I'm multiplying it by 33, hopefully you can see that 33 and 33, you have 33 in a numerator, right? And then 33 in the denominator. So if you have the same number in the numerator as you do in the denominator, it cancels out. So 33 will cancel with 33, and what you're left is just 48. So using these sort of tactics, we can use unit analysis to arrange different unit conversions that allow us to solve problems. So what I mean is, let's do an example here. So Mr. Cho wants to throw the school a pizza party. Each student will get 3 slices of pizza. One box of pizza has 12 slices. How many boxes does he need? By the way, there's 523 students. So we're going to highlight all of the important information here. So all the important information is information that has a number associated with it. So the first one that we have here is there's 3 slices of pizza per student. So each student gets 3 slices of pizza. Another piece of information is 1 box of pizza has 12 slices, and there's 523 students. What we are looking for here, the last numerical value that's not given to us, but we're looking for it, is the number of boxes. So our givens here are these yellow highlights. So each student gets 3 slices of pizza. So 3 slices per student. 3 slices per 1 student. And when I write this sign like that, when I write this sign like that, that's the same as saying 3 slices over 1 student. That's the same thing, okay? 3 slices per 1 student is what that dividing sign basically tells us. So that's the number of slices each student gets. 1 box of pizza has 12 slices, so 1 box for 12 slices. So 12 slices per 1 box. Okay, so those are some of our conversion fractions. Or conversion ratios, it's the same thing, conversion factors, again, all the same thing. We also have this value here, the 523 students. That's not a conversion, that is, instead it's like what we are working with. So 523 students is what we're working with. That's not our unknown, let me move that over. So in this problem, we don't have traditional units. We're using slices, students, and boxes as the units. The unknown quantity in this is the number of boxes. So actually, let's write that further up here. Number of boxes is our unknown, and that's the unit that we're looking for. I'm going to move this up so we have a little more space. So when setting up this question, we're going to start with the unknown on the left side of the equation. So number of boxes equals. So the first thing you're going to start with is the number that does not have a fraction associated with it. And so the number that doesn't have it is the students. So 523 students. Now our next part is we need to find a conversion fraction that's going to cancel out the unit students. And in order to do that, we are just going to scroll right up here to this example, the 33 and the 33, canceling out. So in this example over here, the numbers canceled out, but what we want to cancel out down here is the unit. So if we have students and divide that, let's actually switch back to this, and divide that by students, then we're going to get those to cancel out. So what we really want is we want students to be in the denominator over here. So of our 2 conversion factors, we've got 3 slices a student and we have 12 slices a box. So we're using this given here because there's students there. There's no students in the second one. So we're using the first one to cancel out. And we want to arrange this so that we have students in the denominator down here. So students, so one student goes in the denominator. And then in the numerator, we'll have 3 slices. Keep in mind that, actually no, I'll talk about that in a second. Okay, so now, hopefully you can see that the students is going to cancel with the students. Must be in the denominator, okay? Now the next part, we have another fraction we need to look at because we're not quite there yet. See how we're at slices now? Slices hasn't canceled with anything. We're looking for boxes and we're only at slices right now. So we've used this guy. We've used this guy. Now this one is our leftover or our last conversion factor. So we want to arrange this fraction so that slices cancels out with slices on the denominator because slices is in the numerator right now. We want it to cancel out with whatever's down here. So we want slices to be in the bottom. Right now, slices is in the numerator. And so we need to flip this fraction in order to get slices in the denominator. And when I say flip the fraction, you're not just flipping the unit because there's 12 slices in one box. It's not 12 boxes. So this is not the same as 12 boxes per one slice. Right? That is just ridiculous that you wouldn't have one slice divided into 12 boxes. So the unit slices is attached to that 12. So we can't write our fraction like this. We have to flip the numbers and the units. So we have one box or boxes per 12 slices. So now we can say that, yes, those are equal. So that this right here is what we're going to use over here. So we now have slices in the denominator, so 12 slices. And that will cancel, right? That slice and slice will cancel. And we have one box in the numerator, or one boxes, whatever. Obviously, we don't write one boxes. So all of our units here have canceled. Cancel, 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 cancel. And we're left with box. Is that what we're looking for? Yes, it is. Perfect. So now when I put that in the calculator, all I'm typing into my calculator is 523 times 3 divided by 12. However your calculator does the divided by, it could be like divided by like that. It could be in a fraction, like this. Either way, any of these ways, it's all the same. So when I plug it in my calculator, I can just directly type into the row 523 times 3 divided by 12. You could put it in like with the ones. So what I mean by that is 523 times 3 divided by 1 times 1 divided by 12. Any of these ways works just fine, as long as you're dividing by the correct number and multiplying by the correct number. So when I put that in the calculator, just pause for a second and do it for yourself and see if you get the same answer. 523 times 3 divided by 12. I get 130.75 boxes. Make sure that you have the unit there. And I can't have 0.75 of a box, a pizza box, right? So I need to round that to my nearest whole number. So 131 boxes. Okay. So hopefully this helps in understanding how unit analysis works.